Did you guys get it printed? All right, excellent, excellent. Okay, so I started super basic just in case you haven't watched today's lessons yet and you just decided to pick up here. So when there's multiplication, if there's no variable, I would put a 1, even beside your whole numbers, because you're going to run into problems when we start working on our properties tomorrow, where the whole numbers you're going to distribute through. So if I would start today, like if you're writing something down, put a 1 there as sort of as a space holder and to hold you accountable, because otherwise you kind of forget there's a 1 there. And when we are multiplying, so when you multiply, you add the exponents. There's not another constant 3, and you add them only when their bases are the same. So if you look at this, we have a b and a b. So if you were to rewrite it, I would sort of look at it like that, like regroup it, because remember 2 times 4 is 8 and 4 times 2 is 8. So the order is not hugely important, but remembering that they're all, in this case, 3 different things. There's nothing to multiply 3 by, so 3 is it. And then b1, we add those together. That's going to be b squared. So then looking at number 2, again, I would pull out, so 2 times 3 times 2, because those are all numbers, so like bases per se. Then I have n to the 3rd power times n to the 2nd power times n to the 0 power. So 2 times 3 is 6, times 2 is 12. So we're taking care of one thing at a time. And then these are multiplications, so we're going to add all the way through. So 3 plus 2 is 5, plus 0 is still 5. So it's going to be n to the 5th, fifth power. N to the 5th power. And make sure when you're typing this in, if you have to type it in, either that you do n up caret 5 or use your equation editors or text, like where it'll bump it up in Edpuzzle. Make sure you put it up though, because if you just put n5, that is not correct. N up caret, in case you don't know where it is shift 6 on your computer. So that's not an excuse to miss out on that either. Another just call out to a law. So n to the 0. So anything to the power of none, which is 0, is 1. So this guy basically cancels out and is 1, because anything times 1 is itself. So that's when they say cancels out in some of your Edpuzzles or other YouTube videos, and the way other people, it's just a conversational difference that it goes away, but it's because when you multiply by 1, it really changes nothing. So the final answer is 12n to the 5th power. The 12 is not to the 5th power, just the n. So be careful if you decide to throw parentheses around this guy. The parentheses would have to go around the whole thing. So I could put parentheses here and it'd be correct, or 12 times n to the 5th power here, but you do not want that 5 attached to the 12, because it's not. It's attached to only the variable base n. Number 3, so I have b2, so I will pull out my numbers. Then I have b squared times b squared. So 2 is not multiplied by anything, so it's going to be 2. And then squared and squared, since we're multiplying, we're going to add. So that's b to the 4th power, and you're done. Because what that's saying is how many b's are there? And if we extended this out like longhand, there's 4 of them. B squared means b times b. And if I times that by b squared again, it's b times b times b times b. So that's b times itself 4 times. That's why the addition works. So number 4, again, we could pretend like 1 times 2 if we're writing everything out. That imaginary 1 there, because there's not an exponent there. So p squared times p with a 1, because there's not an exponent there. That's going to give me 2. And 2 plus 1 is 3. So our final answer is 2p cubed. These you may be able to just look at and see and boogie straight across without breaking things up, but hopefully you're paying close enough attention to me breaking these up, because they are EOC level questions are not going to be that easy. There is going to be a little more where you need to have to make sure you're paying attention. There's usually not just one variable. So this is me just starting out. So as long as you're sitting here rolling your eyes being like, why does she write that much? That's why. It's just to show you the process when it's super easy and easy to track. So this one again, so I have whole number divided by whole number and x divided by x. Not complicated in this case, but I would practice pulling it apart again, because when they get really big and fuzzy and wild, it's literally matching up the things that match and pulling them in and then pushing them back together. So 2 divided by 2 we know is 1. So we know our answer is going to be 1. And then 1 and 1. Division, we subtract. So when we divide, like bases, we subtract the exponents. So 1 minus 1 is 0, so x to the 0 power. But we know anything to the power of none is 1, so this actually becomes 1 times 1, so our answer is 1. That's using your rules to know so, but remember, anything divided by itself is 1. So you may have seen the 1 before I even just explained that the long way. But that long way is just using, again, those skills that you're going to need later when it's not quite so obvious. So I have 2 over 1 numerically. The next variable is v, so I'm going to do v squared, and there's v cubed on the bottom. So 2 divided by 1 is still going to be 2. 2 minus 3, so top minus bottom. So 2 minus 3 equals a negative 1. So theoretically, that's going to be 2v to the negative 1. A negative exponent. So the way I like to talk about it in class, it's a little harder because you can't see me because you're going to miss out on all the dancing and everything. All numbers are over 1. So we're up at the top. We're in the numerator right now with that negative 1. So if you see a negative 1 in the numerator, we're going to have a dance party because it's negative. We're going to change the attitudes of everyone and make them back positive. And when it's in the numerator, you're going to drop it like it's hot. And that V is going to go down into the basement. And I believe one of the Ed puzzles talks about reciprocals, which is way mathier and probably way more accurate as far as a teacher should say. But I like drop it like it's hot and raise the roof. If it happens to be in the denominator, we're going to raise the roof and put it back up in the numerator. So again, changing it from a really crappy attitude, because again, if you were sitting in my classroom and I started dropping it like it's hot or raising the roof, hopefully you at least giggled and your attitude would become positive. And in this case, our exponent would become positive. So our final answer is 2 over v. Usually if there's any time there's a fraction, I would say leave it over the bar all the way through, like even with an imaginary 1. If you moved everything up and there's a 1, leave it there in case something along the way makes things flip. So you remember, it's easy to forget that a whole number really still is a fraction. It just has that imaginary 1 underneath it. All right, so look at number 7. We have a 2 over 3 x cubed. 2 over 3 cannot really be simplified. It makes a decimal, and in exponential rules, we are keeping our, like I said, our numerator and our denominators, or like I said, raise the roof or drop it like it's hot. Those things stay. So it's never decimal with a bunch of variables behind it and exponents. It stays in fraction form. So if it can't be simplified or reduced, leave it as is. So that's a 1. So 1 minus 3 is going to give me a negative 2. So I now have x negative 2. Again, we're up in the numerator, so we're up at the top, being negative. So we're going to drop it like it's hot and be all silly and make it positive. So we're going to drop it like it's hot. So it ends up 2, 3x squared is now on the bottom. So the exponent stays the exact same number. It doesn't change numbers. It just switches its power. So it was negative, now it becomes positive. Because you never want negative exponents. You don't want to leave 0 exponents either. Those are the two that you have to manipulate and get rid, or quote unquote, get rid of. So this one, ideally, it's a 1 over 3 and 0 over n1. So if we're sticking to the rule, maybe you already see some fun things and probably could have gotten to the answer without even having to think into it. But if you're sticking to the rule and using the properties, 1 over 3 stays the same. It can't be reduced. 0 minus 1 gives me a negative 1. So that means n to the negative 1. But you can't have a negative exponent, so we're going to drop it like it's hot and then laugh because your teacher's dropping it like it's hot, and it becomes a positive 1. But that 1, remember, is assumed, so you don't have to write it in your final answer. And I'm pretty sure in Desmos they don't like it if we ever get to use, Delta. In Delta Math, I'm pretty sure they don't like the imaginary 1, so don't put it in Delta so we don't accidentally get one wrong just because. The other way you could have gotten to this answer is anything to the power of 1, power of none is 1. So there's your answer right there. Same as here. How you got there, I mean, when they get wild and fuzzy, there's only some mild have-to rules in which order you do it and how you get there. But as I've said 100 times before, it's not as important how you got there necessarily. It's just important that you're getting there correctly, like mathematically sound, and you're not teaching yourself a bad skill for later when it might matter the order. All right, so now we're getting into more EOC style or really math 1 level questions. So we have lots of variables, double variables, lots of things. So I have 2 to the 1, 3 to the 1, because again, we're going to practice making sure there's a variable attached, exponent attached to every base. So I have 2 times 3, and those are ones and ones. And that just took care of my numbers. I have a to the 0 times a to the third, b to the 0 times b squared. We don't want to turn these into ones yet, these guys into ones quite yet, because it's going to make a difference where they are a little bit for some of us. 2 times 3 is 6. So 0 minus 3 is a to the negative 3. 0 minus, this is plus. Woo, Lord bless. Look at me making stuff up. Sorry. Switch from division and multiplication, and my brain didn't come with me. 0 plus 3, because this is multiplication, and multiplication we add. So it's going to be a to the 3. So you absolutely can go ahead and go boom, boom, gone, 1, 1. 2 times 1 times 1 times 3, still 6. And we're left with a to the third power. 0 plus 2 is still going to give me b squared. So it's a cubed times b squared with a 6 in the front. And I do the dot. Probably your answers usually are going to look more like that. Again, it's just a notation teacher difference. It's really the same thing. Because remember, 4x is still 4 times x. It's not one thing. It's 2 numbers. 4 times some number. So in this case, it's 6 times some number cubed times some number squared. It's multiplying all the way through. So if we had an a value or a b value, you would come out with a final answer. But because there's letters, we stop there. All right, so this one we have a 1 in the front, 1 variable on the y. We could put a 1 variable on the 1 exponent. Sorry, my vocabulary, my words are not working for me today, guys. Sorry. 1 times 3 is our numbers. I just go left to right, so I took care of my numbers. Then I have a y1. I don't have another y1, so then I have an x to the negative 2 and another x negative 2. This is multiplication straight across, so it's 1 times 3, which is going to be 3. Y to the 1 is just y. So if we want to start putting our answer together to the side, that's fine. And then negative 2 plus negative 2 is going to be x to the negative 4th. Super close to done, but not. Because remember, no negative exponents. You cannot be left with negative exponents, so we have to fix it. So remember, it's always over that imaginary 1. We're going to drop it like it's hot. Use the exact same exponent. We're just changing his attitude. So he's no longer negative, he's positive. So our final answer would be 3y x to the positive 4 in the denominator. X to the positive 4 in the denominator. I usually ask this and nobody does, but is everybody so far so good? Questions? Want me to go back and say something different about one of them, or are we good to keep boogieing? Thank you. I appreciate those of you that answer a lot. Okay, so I'm going to keep going. We're going to finish these 20 before time runs out. So we're still multiplying. So we have an x to the third power. You want to look down your list. There's no more x to the third powers, so we're done with him. Y to the negative third. Maybe you think, oof, but don't put oof yet. Go find another y. There's a y0, so that one's taken care of. And then we have a whole number 2. Your numbers are usually in the front, so 2. X cubed, x to the third power. There's not another one, so we can just translate that. So you're taking care of those. Y to the negative 3, so negative 3 plus 0 is negative 3. So y to the negative 3. Or again, as soon as you saw that y0, you could know that's just a 1 and not even have to deal with the y's either. But you're not done. Can't leave a negative exponent. So since it's a negative, we're going to drop it like it's hot. It's going to go down into the denominator from the numerator. So 2x cubed, still at the top. Nothing changes there. Y comes down to the basement and his attitude changes. So he becomes a positive 3 exponent instead of that negative 3 exponent. Number 12. So you have a whole number 2. No other whole numbers. Y to the negative 2. No other y. And x to the 3. No other x. So this guy, we're basically just having to fix that negative exponent with that y. Can't have negative exponents. Ever. Can't leave them. So we're going to change this attitude. Drop it into the basement. So 2x cubed all over y squared. It becomes positive because we took the reciprocal, or like I said, dropped it like it's hot and put it in the basement instead of leaving it, or in the denominator, instead of leaving it in the numerator. Now, division. These are the ones that usually people start to panic because they get really big and you start using multiple rules. So what I cannot reiterate enough is just slow down, start left to right, I would do top first, bottom first. See if you can simplify, just like you would in a regular equation, like left side, right side, get it cleaned up, then get to work. And then just match up the things. So we see this is division. So we know we have a 1/2, because that's the first thing. Then the next variable I run into is an x, and that's x to a -3. And then on the bottom, there's an x. Check those off. Now we're going to y cubed, then y to the -1. And now we're just going to go each set and simplify, and then we'll clean up and put it together at the end. So we know we're going to have 1/2. And I just usually draw my line a little longer because I know I'm going to eventually add things to it. -3 is division, so we're going to do -3 minus 1, which is going to give me x to the -4. Hopefully that's already sending off a bell. We know we can't leave that alone, so we do have more work. But +3 minus a -1, that minus a negative, remember, makes it positive, so it turns it to addition, 3 plus 1. So we're going to have y to a +4. So my line got extra long, or extra excited. All right, so from there, the 1 in the front is imaginary, so it's going to go away in your final answer. It's probably not going to be there. But you also have that -4, which is a problem, so it's going to drop down into the basement. So drop it like it's hot when it's negative so you can laugh at your teacher. Y to the 4th is still at the top because nothing was wrong with y to the 4th. His attitude was great. He gets to stay at the party he's at. 2, and then x to the 4th. He went to a new party or down in the basement and became positive, and so we took care of all the issues, and it's rock and roll from there. It cannot be reduced any further, because they're not like terms, so you can't really combine anything else. So that would be your answer there. And I think some students have a hard time leaving it, quote unquote, that messy. It's kind of like the literal equations. You have to stop. That's all you can do. You're done. Look at number 14. There's not a number here, but so we know we have 2/1 as far as our whole numbers. And ideally, again, you'll see the purpose for those. They are raised to an imaginary 1 exponent. You'll see that purpose more tomorrow with the 2 new rules. I have u to the 3rd, u to the -1, moving right along, v squared, v -2. 2/1 does not simplify. Doesn't get any better, any cleaner, any nicer. So then we're going to look at 3. It is division, so it's 3 minus -1 again. That minus becomes a positive. So let's go u, 3 plus 1, so that's 4. 2 minus -2 is v to the 4th power. Nothing has to drop into the basement, so that imaginary 1 is probably not how you're going to see your answer. You're probably going to see your answer more like that. Now, that's the way I do it in my head, or the way I do it on my paper even, for that matter. Some teachers I have seen, though, as soon as you see those negatives, just move them to the top, and you would work it through as a straight multiplication problem in that instance, because once it moved up, it's v to the 3rd times v to the 1, which would still give you, u to the 3rd times u to the +1, which would still give you u to the 4th. It's whichever way makes more sense to you. I like to keep them nice and neat in their rows, use my rules, and then clean up. But both are mathematically sound ways to get there. All right, so 2 divided by 2, so the same thing divided by the same thing is going to be 1. The same thing divided by the same thing is 1, so our answer is 1. Or 2 divided by the division m squared, so 2 minus 2 is 0. M to the 0, anything to the power of none is 1. 2 divided by 2 is 1, so longhand it'd be 1 times 1, which still gives you 1. So anything divided by itself is 1, and then anything to the power of none is 1. Looking at 16, again, we're going to break it up. So we have 3/2. We're running right down our line left to right. So x squared with a -2 at the top, x -2, y -2, y cubed. Starting from left to right. 3/2 again cannot be reduced. It can't look any better than that. Can't simplify, make it smaller. No decimals. Do not turn them into decimals. Do not turn them into decimals. -2 minus a -2, that becomes a plus. So -2 plus 2 becomes a 0. So x to the 0. And I'm just writing it out all the way through. Hopefully somebody in their mind just thought, ding, ding, ding. Power of none is 1, so it goes away. But we'll finish it up first. -2 minus 3, because it's division and we subtract, is going to give us a -5. So we still have to clean up anyway. So x to 0 is 1, so 3 times 1. Still going to give me 3/2. That negative is a problem, so we're going to drop it like it's hot, put it in the basement, laugh at our teacher, and become positive again. Go to the party, whatever story makes sense to you. Or if it's just the rule, then that's fine too. Once it's reciprocal, so it goes from the top to the bottom, it becomes positive. Now, if the negative had been in the bottom and that was it, like it was given and there's not another one on the top, then you're just going to move it to the top and become positive. It flips from numerator to denominator, depending where its original location is, and switches signs. All right, these are really, really great EOC ones because we have multiplication across the top, but it's still division. So you are literally going to, please, do not panic. Do not panic. That is what you're going to do first. You're going to take a Post-it note, a card, anything that you can do to cover things up because it is overwhelming. First and foremost, you're going to clean up the top. So we're not even looking at the bottom at all. We're not even getting the division part. We're just going to multiply. So we know we have a 3 times 2. I have an x squared. Again, just working left to right because that's how my brain works. And then I have an x cubed. Then I have y to the negative 3 times y. 3 times 2 is 6. When we multiply, we add. So 3 plus 2 is 5. X to the 5th power. Negative 3 plus 1 is going to be a negative 2. So I now know that on the top of this fraction, I now have 6 x to the 5th y to the negative 2. Now, if you want, you can go ahead and push that y to the negative 2 to the basement because you know he's negative and he has to go down to switch to become positive. Or we can work straight through and do it at the end. So now we're going to do the same kind of idea. We're going to simplify and separate. So it's 6 over 3, x to the 5th, x to the 3rd, y negative 2, y 0. So again, just matching up the things that match. 6 does simplify when divided by 3 to a positive 2. But remember, I said keep it as a fraction because things are going to move around from numerator to denominator. It's division, so 5 minus 3 gives me 2. So x squared. Negative 2 minus 0 keeps that negative 2, so y negative 2. That's our problem because we can't have a negative exponent. We kick him down into the basement. He's glad to be away from us. So he's positive again, y squared. And again, those exponents need to be written if it's handwritten, where you can tell it's not on the same line of notebook paper as the y. It is in a subscript or superscript. It's up in the air, not down at the bottom, not equal with y. All right, so one thing at a time again. Let's see if I can get rid of that. So if you look at the top, I like the top because there's a 0 there. So I would do this because that would make me excited because that y to the 0 goes away because that's a 1. And 1 times anything is itself. So that means I know I have x squared by itself at the top. If you want to write it there, we can to hold on to it. But we're still going to ignore the top because we have a little more cleaning up to do at the bottom because there is a multiplication there. So I have 2. There's not another whole number. I have x times x squared. And then I have y negative 2. 2 is going to stay the same. He's in the basement too. So x squared. So 2 is 2. I have 1 times with a 2. So 1 plus 2 is going to be x cubed. He's in the basement. Don't forget, don't all of a sudden push him up to the top. The only way they get to cross that line is if they were negative. Otherwise, they have to stay in their seat, stay in their place. Y negative 2 would also be on the bottom, but we don't want to leave him in the bottom because he's negative. So this is where I said if it was in the denominator, then he has to push to the numerator to become positive. So that's going to be your x squared y negative 2 over 2x cubed. Hopefully you know we're not done yet because now all we've done is cleaned up the bottom, cleaned up the top. Now we have to actually divide. The only thing that matches top and bottom is your x squared and your x cubed. So x squared, x cubed. And it's division. I wrote it as multiplication because multiplication is so much more fun than dividing if you ask me. But when you divide, you subtract. 2 minus 3, which is going to be x to the negative 1. So that would go up to the top. So x negative 1, y negative 2. 2 still on the bottom because we didn't change him. It's still 1/2 in theory, that 1/2. Those two negatives can't exist in the top. They can't exist in the numerator. Sorry. We're going to push them down to make them positive because they can't stay negative ever. Oh, and I lied. That's a positive 2. We already fixed him. That's how he got up there to begin with. That should be a positive 2. So he hangs tight. So the only problem is our negative x. And I can't get to erase. Sorry, guys. Oh, there we go. So y squared is still hanging on to the top. Disregard our arrow. He was a well-behaved, positive person doing what he was supposed to. 2's already in the bottom because he stayed in the bottom because he didn't do anything to move either. And then x, imaginary 1, assumed exponent, is with that 2. I'm going to do one more because I know we're pushing it on time. Clean up the top first, and I'm not going to actually cover it necessarily so you can see what I'm doing. So 2 times 3. So I took care of our whole numbers rewriting. X cubed times x squared. I know you guys are going to fight me on writing this out this way, but some of it's just beating yourself at your own game and not psyching yourself out. So we know too easily that 2 times 3 is 6. We know when we multiply these guys, we add. So that's going to be x to the 5th. Multiply these guys, we add again. So that's y to the 5th. So we now have 6x to the 5th, y to the 5th, all over 3x cubed. Division, we're still going to break it up. So 6 divided by 3, x to the 5th, over x to the 3rd. And then y to the 5th. Make sure you put a 1 underneath there, even though there's nobody to match up with him, so you don't just accidentally push him into the bottom. He does stay in the numerator because that's where he belongs, and he hasn't done anything to get kicked out of there yet. So 6 divided by 3 is going to give us a 2, and that's going to be in your numerator. So you can put a 1 if you want to, again, to hold your spaces. 5 minus 3 because we're dividing. X is going to be to the 2nd power because 5 minus 3 is 2. And then y to the 5th is still at the top, so it's all good. Nobody had to get pushed into the basement, so your final answer is 2x squared, y to the 5th. And guys, since we hit our 30-minute mark, I don't want to overwhelm you or over-teach you or waste your time. So that is all of the review I have for your 0, negative, division, and multiplication rules of exponents.